Dear children, this numerical is based on Newton's laws of motion. So look at this numerical, children. So here M1, M2 are arranged like this actually. Of course, M1 is a 10 kg, M2 is a 5 kg. But here one assumption is made such a way that just M2 and see M2 is just moving downward direction such a way that M1 will go right side. And in the question it is given that actually this M1 block is stopped with the small nail. So as per the assumption made, if you can remove that nail, what happens? Then M1 starts sliding right side, simultaneously M2 will be going downward direction. As both are in motion, children, obviously they are accelerated, which means what? The system has some acceleration. So obviously as the bodies are suspended by means of a string, there will be a tension also. So now in the given numerical, it is asked us to calculate the acceleration and as well as the tension developed in the string. First let us calculate the acceleration, then we will move to the tension, children. So here a simple concept, just we are going to apply the concept of free body diagram. So first children, let us make a free body diagram for mass M1. So for this M1 body, okay, so let us assume that it is a point object mass M1 and tension force T is acting. Children, upper direction, normal direction, downward direction weight, both will get balanced. So no need to consider because the body does not move along the vertical direction because the net force is 0. As the body is moving horizontally, which means what? There will be a net force along the horizontal only. So here only one force acting, that is the tension. So whatever the net force which is acting is equal to tension. So how to calculate the net one force, children? Mass into acceleration, that is T is equal to M1A. So let us say it is the equation 1. Now let us consider the body 2, children. So for body 2, so it is a mass, okay, its weight M2G is acting downward direction and tension T will be acting vertical upward direction. So as per the assumption made in the numerical, as the body is moving downward direction, children, obviously M2G is greater than the tension. Okay, so here M2G minus T is equal to F net. So as per the Newton's second law of motion, M2G minus T is equal to mass into acceleration. Now get this M2A this side, so take a tension right side. So that is M2G minus M2A is equal to tension T. Children, now let us compare the equation 1 and 2. As here LHS, of course tension, if you can write this side, LHS will be equal. So as tensions are equal, these terms can be equated. So that is from 1 and 2, children, it can be written as M2G minus, so here I think M2 we can take as a common, okay, leave it, M2A is equal to M1A. So take this side because we need acceleration term. So here M2G is equal to, here I think A we can take as a common, M1 plus M2 into A. So acceleration is equal to, children, M2 by M1 plus M2 into G. So this is actually expression for the acceleration. In fact, dear children, you can use direct formula. If you can remember, you can use direct formula also. So with this formula, we can calculate the acceleration. First, let us see here. So substitute the values in this. So acceleration is equal to, so M2 is 5, children. Okay. M1 plus M2 is 10 plus 5, that is 15. And the G value is 9.8. So 5 ones are 5 3s are. So it is a 9.8 by 3. So this will become 3 3s are 3 to the 6, approximately 7. So 3.27 meter per second square. So with this much acceleration, both bodies will get accelerated. I can say it's acceleration of the system. Now children, we need to calculate the tension, right? So here substitute the A value in equation 1. So in this you can substitute. So then T is equal to, M1 is equal to how much, children? 10 into 3.27. So T is equal to 32.7 newtons. Here you may get a one doubt. Sir, why can't we use the equation 2? Yes, you also can use it. You will get the same value. If you want, just you can try, children. We get the same value. Okay, now fine. So this is a acceleration of the system is 3.27 into meter per second square. The tension developed is 32.7 newtons. And here one more question is asked in this. So what will be the tension produced if system will be in system comes to rest, children? So system comes to rest means what? No force acting, net force is 0. So as system coming to rest, net force is 0, obviously acceleration also 0. Children, when the system comes to rest, children, if the system comes to rest, then let T dash be the tension, and obviously net force won't be there, so obviously acceleration 0. So in that case, let us say the tension developed is T dash. Let us say that T dash is a tension developed in the string when the system comes to the rest. So then in that case, what will be the tension? If the system comes to rest, then what will the tension acting in the string actually? So for the children, so let us use the equation 2. So M2G minus M2A is equal to T. So let us use this. M2G minus M2A is equal to T. In the place of T, we are going to take a T here. Why? Acceleration we are going to take a 0. Children, it is not our wish. In the numerical, it is mentioned that system is coming to rest. If system comes to rest, they mentioned. Okay, fine. So then this term will be 0, right? So then T dash is equal to M2G. So M2 value is how much, children? M2 is 5 into 9.8. So this will be 45. So 49 newtons. Is that, children? So it's very simple. So these kind of questions, whenever we are solving, children, we should have patience, because in the place of minus, if you can take a place, or else if you take a M to a left and a T will come right side, in the place of the tension finding in the system, we get the tension. So let us not any kind of tensions. Okay, na? So our focus should be on the tension asked. So we should not take a tension. Is it clear? Okay, na? Just copy this and just practice a similar kind of numericals. Okay, children. Thank you.